Today I want to concentrate on systems, which is part of the systems design master of this title. And I want to introduce systemic thinking and the theory of living systems from the point of view of sustainability and ecology. As our new century unfolds, one of our greatest challenges is to build and nurture sustainable communities, that is, social, cultural, and physical environments in which we can satisfy our needs and our aspirations without diminishing the chances of future generations. Since its introduction in the early 1980s, the concept of sustainability has often been distorted, co-opted, and even trivialized by being used without the ecological context that gives it its proper meaning. So I think it is worthwhile to reflect a little about what sustainability really means. You see, what is sustained in a sustainable community is not economic growth or development or competitive advantage. What is sustained is the web of life on which our long-term survival depends. In other words, a sustainable community is designed in such a way that its ways of life, its technologies, and its social institutions honor, support, and cooperate with nature's inherent ability to sustain life. The first step in this endeavor, naturally, is to understand how nature does it. How does nature sustain life? How have ecosystems evolved to sustain the web of life? This understanding is what I have come to call ecological literacy or eco-literacy. In the coming decades, the survival of humanity will depend on our ecological literacy, on our ability to understand the basic principles of ecology and to live accordingly. As far as science is concerned, the most appropriate framework for ecology is the theory of living systems. And this is going to be a big part of my 3-day course. This theory is only now fully emerging, but it has its roots in several fields that were developed during the first decades of the 20th century. Fields like organismic biology, cybernetics, gestalt psychology, and so on. Examples of living systems, which were studied in all those fields, abound in nature. Every organism, an animal, a plant, a microorganism, or a human organism, is an integrated whole and therefore a living system. Parts of organisms are living systems too. For instance, leaves of a plant or the cells of an organism. And then we have communities of organisms, like ecosystems or social systems. Throughout the living world, we find systems nesting within systems. We have, for instance, we are part of a social system. Every one of us is an integrated organism, a living system, which contains organ systems like the nervous system or the digestive system, where we actually use the word system to describe them. And then each organ is a living system. Each tissue of an organ is a living system. And each cell is a living system. So we have systems nested within systems. The difference between a living organism and a dead organism lies in the basic process of life, in what philosophers and poets throughout the ages have called the breath of life. And this breath of life, in modern scientific language, is called metabolism. Metabolism is the ceaseless flow of energy and matter through a living organism or any living system, through a network of chemical reactions, to be more precise, in biological systems, through a network of chemical reactions that enables the living organism to continually maintain itself, regenerate itself, and perpetuate itself. So metabolism is the key concept that allows us to define biological life. And the understanding of metabolism has two basic aspects. One is the continuous flow of energy and matter. All living systems need energy and food to sustain themselves. And all living systems produce waste. That's part of metabolism. But life, as you know, has evolved in such a way that it formed communities of organisms, the ecosystems, in which the waste of one species is food for the next. And so there's no net waste in an ecosystem. The second aspect of metabolism is the network of chemical reactions that processes the food. The energy and matter, of course, that come into the organism are the food. And this network of chemical reactions forms the basis of all the functions and behavior of the organism. The emphasis here is on network. One of the most important insights of the new understanding of life, which actually goes back to the very beginning of systemic thinking in the 1920s, is the recognition that networks are the basic pattern of organization of life. In conclusion, I want to emphasize that my extension of the systemic conception of life to the social domain explicitly includes the material world. As I said, it is an integration of three components, three dimensions of life: the material, the cognitive, and the social, or the biological, the cognitive, and the social. Now, for social scientists, this is very unusual to have matter included in the social sciences, in the social conception of life. Because traditionally, the social sciences have not been very interested in the world of matter. Our academic disciplines have been organized in such a way that the natural sciences deal with material structures, while the social sciences deal with social structures, and social structures are understood to be essentially rules of behavior. When it comes down to the basics, a social structure is a set of rules of behavior. In the future, this strict division will no longer be possible, because the key challenge of our new century for social scientists, natural scientists, and everyone else will be to build ecologically sustainable communities. And they need to be designed in such a way that its technologies and social institutions, in other words, its material and social structures, do not interfere with nature's inherent ability to sustain life. In other words, the design principles of our future social institutions must be consistent with the principles of organization that nature has evolved to sustain the web of life. And to create such social institutions, we need a unified conceptual framework for the understanding of material and social structures. And this is the one that I have briefly outlined and will discuss to greater extent in my course. Thank you very much for your attention.